Good day, everyone. Hope you're well. Just before starting our session here, I see a couple folks are joining in. So we'll take 2-3 minutes and make sure everyone's here, and then we'll go ahead and start. All right, so we're getting ready to start. Welcome, everyone. So I'm Sebastian. I'm the sales manager for the Analysis and Design Solutions, and I'm here today with Farshad, who's our senior application specialist, who will be driving the more technical side of the presentation. So I'll get things kicked off. Welcome, everyone. We're here today to present to you an advanced analysis and design tool for all your steel connections that can be used obviously for your bridge connections, and it'll be used by the component-based finite element analysis, the CBFEM, and obviously according to CISC codes. So we'll show you how we can use this tool for all your bridge connection needs. So today's agenda, I want to do a quick presentation on the Greatech Group, but the main focus today is on the advanced design connection software for bridge connections. So I'll do that very briefly. And then as you can see here, with the introductions, the overview, etc., their main goal is to go through the software, show you how it works, how we do the modeling, the analysis, the design, get our reports specifically for bridge connections. And then we'll also see with our ADA model from our bridge software how we can work together. And finally, we'll taper off with an example of one of our customers and a success story. All right, so who is Greatech? What does Greatech do? So we have two main hats. We're a software developer, so over 30 years experience in CAD, BIM, design solutions. And we're also an Autodesk reseller. So we're actually the third biggest worldwide reseller, and we operate in over 36 offices now, over 450 employees, already growing. And we have a global reach, obviously, with our network of authorized resellers. We have a local North American team that develops, supports, and localizes all our software for the Canadian and American markets. So it's a company of over $100 million revenue. So that, in a nutshell, gives you an idea of who Greatech is, what we do, how we have our own software, how we incorporate with the Autodesk ecosystem, and a bit of an idea of who we are and what we do. So with that being said, I'll just go ahead and pass the microphone to Farshad, who will start the presentation on the advanced design connection software.
Thank you very much, Sebastian. So let's continue our technical slides. So first of all, to give you an introduction about ADC, it's a software based on what we call component-based finite element modeling. So as you see, we have a connection here with bolts and I-beams and an I-column. So the basis is software converts these all of bolts or welds and members to components, as you see in these pictures here. So these are the bolts, and you have the shear area in the column web here. So this is what we call as component-based modeling, and all of these components afterwards will be designed based on forces and stresses that has been calculated based on finite element modeling, and based on the forces inside these components, the design will be also provided according to CISC or AISC code. So if I want to continue my slide, so as you see here, the webs and all of the connected members in ADC, they have been meshed using shell elements here. And also, as you know, modeling elements such as welds or bolts in finite element software is a bit complicated, and normally we do not have a special element for those kind of entities like bolts or welds. So here in ADC, we have developed special models for those components for as welds and bolts, which can be used in total behavior of joint and how joint will be calculated based on that. So in this slide, as you see, here is an overview of a graphical user interface of ADC. So here I will go directly into the software to show you menus and features. So here, as you see, I am in the software itself. So we have different menus and features and windows here in the software. So the first one is our icons or tabs here. So it starts from normal and standard Windows icons, so such as a file that we go through our projects. You can start a new one or open the projects. You can define or change your units here. We have our preferences. And after that, here you can add new items or new projects here. So it can start from a 2D frame. It can be a 3D frame. And also we have the anchorage design in ADC. Here in this navigator window, you can go through your model. So let's say go through your geometry, the loads, the design check. So all of these features are available here. So you can navigate in the model. And in the middle here we have another window, which is, we call it data window. So here is a place that you define the parameters for each of the elements in your connection. So it can be each of these members here. As you see here, we have 3 members in this connection, and each of these members you can assign specific parameters like cross section, material type, and other properties. And the window that you see here, which is a graphical window, it will show you the model itself, and you can rotate the model and pan it, and it will be completely rotatable and zoomable. And afterwards you will see that we will be able to view our results as well in this window. So in this slide, as you see, we will talk about finite element analysis and meshing in advanced design connection. So the first procedure to do the analysis in advanced design connection is meshing the element or meshing the components inside your connection. So as you see here, this model here is already meshed, and the analysis have been done on this model. So if we come back again to the model here, and if I want to check for my mesh here, if you go to design window here, you will see the model like this, and in the check option here, if I click the calculate button, software will start the calculation, and it's meshing the element first, and after that it will start some iterations to converge the finite element model. Okay, as you see here, analysis are done. So now you can view the mesh here and the results. So this is the mesh of my connection. So as you see, I have my bolt holes. So we have some special elements for bolts. You see here we have some special elements to model the welds here, and you see the equivalent stress or 1 meter stress on this model like this according to the applied loads here. To apply the loads, we normally use this option here, load effect. So if you go here, you will have a separate window to apply the loads. You can define different load case and different values for your loads. Here you can apply 6 kinds of loads or moments in the structure or on the members. So as you see here, you can do an axial, you can have a shear in both directions, and you can have moment in 3 directions, such as torsion and the other out of plane moments. So after you apply all of these forces, you can run the analysis, and here software will provide you the mesh and the finite element analysis results. You can also view the deflection here. So as you see here, our connection here has large deflections due to this web of our column. All of these deflections are scalable, so you can scale the deformations. Also, we have a tool here to view the plastic strain if it happened in the model. So as you see here, in my connection here, I have some plastic strain distribution or areas or zones, as you see here in my connection. Also, you can have the results separately for the plates. So for example, here in this menu, if I go to the plates section, so here separately I can view the results for the plates. So as you see, when I'm going through this list of the plates, all of the results are here. So obviously this is the plastic strain results, but you can again come back to the equivalent stress results, and here you can go through the plates one by one and inspect the exact equivalent stress happening due to the forces in the connection. You can also view the bolt forces in this menu. So if I activate this option, this icon here, as you see, software also will show us the bolt forces on the model itself. So we have some very useful features and options here. Okay, so here in this slide we will talk about different types of analysis that you can do in ADC. So the first type is normal strength analysis. So as you saw in the slide before, you can apply the external forces or forces inside the members directly to your connection, and software will do finite element modeling and analysis for you and provide the results such as stresses and bolt forces. So this is the first type of analysis that you can do in ADC. We have another type of analysis in ADC that we call stiffness analysis. So the stiffness analysis is also very useful if you are looking for the stiffness of the connection that you have modeled. So ADC will provide you with moment rotation curve, such as the one that you see here. So here, as you see, these are the plastic zone, or this is the location that the behavior of your connection has gone plastic here, and here you have the elastic stiffness of the connection. So normally we use this when we want to have the rotational stiffness of a connection, and in some of the general finite element software such as ADA or advanced design, you can apply the correct stiffness value of your connection into the frame to have more economical design. So you don't need to define the connection or beam to column connection as completely rigid or completely hinge. Using ADC, you will be able to calculate the exact stiffness value of your connection and apply that connection into your general member finite element modeling software, and it will help you to have more realistic behavior and maybe more economical design. The other type of analysis that we have in ADC is member capacity design. So in this kind of analysis, you don't need to apply any forces to the connection. So ADC will start to apply the forces to the connection, and it will, as a result, it will provide you the maximum moment that a member can transfer due to this connection. So the capacity of connection will be provided for the user. And we have also a fourth type of analysis, which we call it joint design resistance. And in this kind of analysis, software will provide you the percentage of the applied load to the maximum load that connection can take. So we have four kinds of analysis in ADC that each of them can be useful for different kinds of analysis. So in this slide, we will discuss about the manufacturing operation and geometry of connection. In ADC modeling, the connection is very easy and it's very fast, because besides the sections and members that they are already in ADC's library and you can just select them, such as HSS or I sections, ADC also has manufacturing operations. So for example, if you want to add a member like this, or some stiffeners, some ribs, openings, and these kind of connections, or even anchorages, ADC already has all of them in the library, and with just one click you can add these operations into your model. So here, as you see, if I go to design section here, so as you see here in my connection, I have different kinds of designs. So for example, I have my welds here, and I will go to simplified or simple view mode. So, and each of these operations, as you see, I can go through them, and software is showing me those with highlighting them by blue. So here I see that I have a fin plate, or here, as you see, I have a weld here. So you can select all of them one by one and apply or modify the properties of your weld or the fin plate here. So there are all kinds of options here that you can modify the weld. So for example, here you can change the dimension of the weld, and all of these parameters are editable here in the software. Also, for example, for fin plates here, you can define the characteristic of bolts, the bolt diameter, and the gap, the overlap. So all of these parameters can be editable due to these manufacturing operations. And in case you want to add a new manufacturing operation or working on a new model, you can just click plus here, and you will have this window. So it starts from a simple cut in your section and it goes to any kind of stiffener. So by clicking each of these, for example, you can add stiffening plates or cut-off plate or even stiffening member to the connection. And after clicking this icon here, a new row will be opened here, and again you can modify it, and it will be directly applied to the connection here. Okay, let's go to the next slide here. So as I mentioned before, ADC can design the plates, bolts, and welds according to CISC or AISC codes. So for the plates design, AISC is just checks for the plastic strain in the plates. So we have a limit of 5% of plastic strain in the plate. So if your plate is having a strain higher than 5% due to forces, the plate technically will not pass, but you can always modify that value. And also we have the bolt results here, and as you see here, we have a report of calculation that how the bolt forces and the resistance has been calculated according to code values and code formulas. So all of these detailed design values are accessible for each bolt one by one. And also we have the same thing for the welds. So you have the detailed design report for the welds based on the code that you have selected. So if I go back to the software, I will show you these features. So here in the check part of our software, so if you go to the bolts here, so as you see here in my model, I have 4 bolts and I have 4 rows in this results spreadsheet here, and I can access the design of each bolt separately here, and as you see here, the status of all of the bolts are green, so all of the bolts are passing. So if I click this plus sign here, the detailed analysis and calculation of the bolt and resistance of the bolt according to the code will be displayed here. So you can closely inspect the design of the bolt. So this calculation is available for each bolt here, and as you see here, when I'm changing the rows, software is showing me the location of the bolt in this window here. And also we have access to weld design. So if I go to this tab here, these are the welds that I have in my model. And again, if I open this tab here, we have the calculation of the weld capacity according to code here, and you have all of the parameters regarding your weld. And the final results for weld, you can always see them here. That in this model, as you see, all of the welds are passing, and here is the design load ratio for the welds design in this specific connection. ADC is completely interoperable with advanced steel or other softwares. So for example, as you see here in this screenshot on the left, I have a connection in advanced steel software. So just with running a simple command in command line of advanced steel, you can transfer your connection or model directly in advanced design connection, and you don't need to define or build the model from the beginning. So it's very easy to send your models from advanced steel to advanced design connection. And also we have another tool in ADC software which we call them templates. So the templates is technically for to facilitate the the modeling effort with the engineer. So let's say you have already built a connection. I will show this template tool in the software. So here in the model, if I go to the geometry, or design, yeah, here in the design section of ADC, here we have an icon which is called template. So as you see, let's say I have built this connection and I want to save this connection and the components, this geometry, in the library, and you can reuse this kind of connection afterwards in your other models, and you will be able to modify the sections, but ADC will keep the connection for you and the number of bolts or geometry, so you will not be forced to start the connection from the beginning. So that's why we use templates. So if you go here and use a create template tool here, ADC will create a template from this connection, and from now on this template will be in the list of the library of templates in your software, and you can always start a model using this template. And also you can save this template as a file and send this file to a colleague, and the colleague can start his model or her model from your template, and they don't need to start to model the connection from the beginning. So you can have all of these templates for your connections or for your projects available in the library. Okay, in this slide I will show you a bridge design example that we have used ADC to design this diaphragm member here. As you see, we have 4 angle sections in this connection here for this diaphragm between my box girder. So first of all, I can show you the full bridge model in Greatech Advanced Design America software. So here is the model in Advanced Design America bridge software. So as you see, the analysis has been done here on this model. So I have my design load ratios, my box girder members, and as you see here, these are my diaphragm. So as you see, the members themselves, they're passing the design, but here, as you see, we have assumed a hinged connection for these diaphragm members. So to design this connection in ADC, you can always have your internal forces coming from your general finite element software such as AD, and after that you transfer these forces and the geometry to those software and model the connection here. So I will show you how to this kind of connection has been built in ADC. So as you see here, we have built this connection exactly as you saw in the Advanced Design America software. So these are my angles. The forces, actual forces that I have put in the angles, they are directly imported or inputted from ADA, or the general finite element software. And as you see here, if I go back, you can see my members here that they have been defined, and then in the load effects section, as you see, I have defined just 2 axial forces for my M3 and M4 angles here, and after that you do the design. So in this case we have welds around these angles here, and also I have weld here for the gusset plate. So all of these parameters have been defined here, and in the check section here, the analysis are done, so you can check the stresses here, and as you see, I have a stress concentration in this portion of the bottom angle here, but plates are passing, and as you see, welds are almost passing, so it's just 0.8% higher, the welds here. Also, in ADC, you can have access for a standard generated design and analysis report for your connections. So here, if I go to report section here, and if I go to preview and print section, so ADC here, it will build automatically a design report for my connection, which includes all of the parameters, the forces, and it has some screenshots of the model and design here. So all of these reports, it can be done automatically. And in your reports, if you want to modify the report or if you want to add some screenshots or table, it's these tools are available here, and you can modify the report. You can delete some sections from the report, or you can add some sections, or you can add screenshots of your models if needed. So this is a diaphragm connection design, analysis and design done by ADC. In the next slide, I will also show you another model or success story that one of our clients, they have used ADC. So here in this slide, as you see, this is a cross-section of temporary support structure for a long span bridge construction. So it's a steel I-beams, and you see the connections here. So in this project, these connections, they have been designed using advanced design connections. So you see the details here, and of course here. So these are the elevation view of the connections, which has been drafted and constructed on the site, and all of the design and analysis process have been done using ADC software. And these are the models for the top portion. So if I go back to my slide here, so I have a beam to this vertical member connection, and also I have my column to this horizontal member connection, two kind of connections here. So the first one, as you see, we have 8 bolts, and the other one we have a bit more complicated connection. So as you see here, both of these, they have been calculated using ADC. So if we go to ADC itself here, so this is the first model that it has been done. And if I go to the results section, so these are all of the manufacturing operation on this model, and for the check, we can just check the connection using ADC. So as you see, the analysis is done here. And for example, for a preliminary design, as you see here, the bolts are almost okay. I have 0.1%. We have some problems with the welds, that welds needs to be modified. So these are, and software, as you see, it's showing these results in color codes. So reds are not passing, and so the oranges are almost passing. So all of these colors here, they are meaningful, and they depend on design load ratio of each component. And also you can have the equivalent stress here on the connection and on the plates. You can have the deformed shape of the connection. And of course you can change the scale for deformation. Okay. Also in ADC, you can do a buckling analysis. So if you have calculated the buckling shape of the connection, you can have access to buckling or local buckling results. So here I will run a buckling analysis also on this connection. So as you see, the analysis for buckling, it's completed. So now we have access to buckling shape of this connection. If you click this icon here, so as you see here, the first buckling or local buckling is happening in the main member here, and it's not happening in the connection itself, and it's almost 24 times of the applied force, so we are totally safe for local buckling, especially in this connection. So as you see, software has calculated 6 buckling mode shapes for this connection, and if I go through all of them one by one, you see all of them, it's happening in the main member. It's except number 5, which is happening in this plate here or in the flange of the I-beam. So as you see, the software can do local buckling also analysis very easily, and it provides complete results and local buckling modes for the user. So this one was the model for the first portion of structure, as I already discussed with you. And also we have the beam portion in this model, which is again ADC used to design this connection. And as you see here, if I do the check for this connection, so analysis is done for this structure also. And for this one, as you see, all of status are okay, so everything is passing here. So you can consult the design results one by one, and also you can have the equivalent stress results here, as you see. And also because for this model also we have done buckling shape analysis, you can have access also for the buckling modes of this structure. So as you see here, the buckling is happening, the first mode of buckling is happening in this member, and you can go and check the other ones as well. Okay, so as you see, all of the buckling mode shapes are happening in this member. So these are the results for our connection here, and as I already mentioned, you can do the strain check also to see where the maximum strains in the connection will happen. So as you see here, we have some high strain values here in this member, and also in the main connection part, strain is starting to develop in this portion of our connection. Okay, this concludes our webinar today. So as you know, you can have access to our free trial for this software for Advanced Design Connection. So you can always send us the requests for free trials to this email address, support.americas@greatech.com. And also we are waiting for your questions about this webinar or about this software using this email, and we will be happily responding for all of the free trial requests and the questions about the webinar. Thank you very much for your time today, and goodbye.